my pleasure right now to introduce Doug Ritterling, who is the Senior Industrial Design Engineer and Team Leader at Electrolux Home Products. He's been very instrumental in making SolidWorks the standard for the major appliance group at the Electrolux Group. Prior to I got to hear this, I don't know how this happened. Prior to joining Electrolux, Doug was a radio and TV announcer for 16 years. So how do you go from radio and TV to industrial design? But I think he's probably most proud right now of his college university. Doug's a graduate of Ohio State University, and many of you know Ohio State was the recently crowned national champions of college football. So with that, Doug, come on up and tell us how Electrolux is using SolidWorks.
Thank you very much. Hi there. Hello, 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 hello. Can you hear me? Okay, great. Can you hear me now? My name is Doug, and I brought toys with me here. And I have this little clicky thing that changes the slides. I'm not talking about that. I'm talking about this Fujitsu stylistic computer. Has anybody seen these in advertisements? Very, very cool. Yeah, there's one right there. I was talking to Steve over here, who is from Fujitsu, and he's over in the partner pavilion. And I think they have 2 or 3 of these things that you can kind of pick them up and take a look. But I thought the really cool thing about this, first of all, you have to see the screen after it lights up. And this thing will boot up. There we go. Can you see that through the light? Just a fantastic screen, and it's all touch screen. And I think it would be something that really works fantastic with SolidWorks, especially in a presentation environment where you have to literally touch. You could do interface design with this thing. Anyway, I wanted to show this to everybody because I just thought it was so cool. Is Erica in the, is Erica? There she is. Could you stand up for just a second? I do not remember Erica's last name, but she was part of the value-added reseller that sold the first seat of SolidWorks to Electrolux. Erica, what is your last name?
It was Lechel, it's Ward now.
Okay, Ward? Okay, thank you very much. She was such a fantastic salesperson. She came in, and this is probably back in '98, and she demonstrated this whole software package to us. Of course, we were thrilled about it because everything we'd seen before was about $27,000 a seat, and we were just blown away by what this SolidWorks package could do for the low prices that she was offering. So we tried 1 seat of it, and that's basically the story I'm going to be telling here. 1 seat of software all of a sudden became very many, and I'm very happy to say that although when I first started writing this speech for today, we were just the standard. SolidWorks was the standard in the United States. Now it's already into Europe now. We're going to be introducing our first seats of SolidWorks in Electrolux Europe in just the next few weeks, okay? Yeah. Have you guys been enjoying yourself here around Disney World? Have you had a chance to walk around the lake and just kind of check out everything? If you do that, really look at all the little details. Do you notice that when you're in different parts of the park, the trash cans match the area in which you're in? Do you notice that if you look for a crack in the sidewalk, other than the ones they put in originally, concrete cracks, you know, well, there's none. There are none anywhere around here. I walked the entire length of it looking for cracks in the sidewalk. That's the maintenance that these people do here. Are you aware that there is an underground city underneath Disney World? Do you notice you don't see trucks going back and forth with all of the, like our breakfast that we have in the morning, our lunch, when the nice hot pretzels come out? You don't see where it comes from. It's all from underground. And what's so amazing is Disney is probably the epitome of considering the entire experience from somebody walking through the door to the time they leave. They consider everything here, and I think that's why it's such a class act. That's what we'd like to talk about with our product design at Electrolux. We have really changed things at Electrolux during the last year, and I was over in Europe for the last 3 months working on this new process, and we're trying to really take into consideration the entire consumer experience from when they walk in the store. What does the booth look like that is holding the appliances? What does the knob feel like when you're turning it? What is the sound that it makes? What's the entire experience of this person taking this product home, opening up the box, pushing it into place, hooking it up, What's that experience like? What does the box look like? What's the sound that door makes as it shuts? What is the feeling that you get from this product? You know, I have a microwave oven at home, and this microwave makes these cute little noises. Unfortunately, it's not one of ours, but it is just fantastic. It plays little songs when it's done. It talks to you. It offers recipes. I want to hug this little microwave. It is just, it's one of those great products that really makes you fall in love with it. And that is really part of the consumer experience. Let me get down to work here. First thing that people always ask me or they'll say to me is, wow, you work for Electrolux. You know, my grandmother had one of those little vacuum sweepers and it still runs and it's 50 years old. Well, no, that's not really us. That company was actually sold by Electrolux back in the 70s in the US. Our company is Electrolux all over Europe and so forth. We're just introducing that brand back into the United States. We bought our name back last year for about the tune of $40 million, but our brand of vacuum sweepers is Eureka. AB Electrolux is the world's largest manufacturer of appliances. We were founded on that high-quality vacuum sweeper that everybody remembers, and we're still based in Stockholm, Sweden, but we have offices everywhere. I'm talking India, China, and all over the world. Here's basically what I'm going to be talking about, how Electrolux USA reduced the product development time, these are true numbers, I checked them twice, by over 100% with 50% fewer designers. After the recent events of last year with the terrorism attack and so forth, the economy went down, and although we didn't get rid of any designers, we didn't rehire when the designers left. And I think a lot of us have had that similar situation. It's fewer people doing more work. We were able to get as much work done with fewer designers with the addition of SolidWorks that we were with an entire staff earlier. Now, am I saying, gee, you can buy SolidWorks and you can get rid of all those other designers and be able to save money that way? No. I'm not trying to say that. I'm saying that when you get SolidWorks on board, it's amazing how much more work you can do, and you can really grow your business that way. I'm also going to be talking about Electrolux USA, our new challenge, which is basically designing for the product experience. I'm going to talk about how SolidWorks is now becoming the unusual center of design. There are all these external little technologies that are coming together. This is one of them that I just showed you, the nice little laptop computer that I pulled up. But there are all these technologies that are kind of hovering around here that help us do product development. And once you bring them all together, it's amazing. SolidWorks is right at the center of that. I'm going to tell you how it works at Electrolux. And then after all that's over, I'm going to show you a few of the things that we've been working on, which are appliances, yet there's a lot of things that aren't really appliances too. Let's give a good example of where we are and where we're going and where we've been. Let's go back. Look at the little guy. Isn't he cool? He's just working away there. 1452, Gutenberg invented the printing press, okay? And that was the beginning of the information age. And then for about 300 years, not a whole heck of a lot happened, but they were really, really thrilled with that little press there. And then about 1793, Eli Whitney invents the cotton gin, and that's kind of the introduction of the industrial age, and also the introduction of interchangeable parts, and that's kind of the birth of industrial design there. Around 1800 passes by, 1900. About 1945, just about the time many of us were born, they had the ENIAC vacuum tube computer, and this computer, it's just incredible. What was it, a 1K computer or something like that? And it was all these big vacuum tubes. It filled an entire room, but that was also the beginning of the computer age. Let's jump forward to 1975 then. There's the Altair 8800 PC that was introduced to give you the laptop computer or the desktop computer that we have today. Not a whole lot of memory, but it was a giant leap to putting things on the desktop. Let's jump forward then to 1995, and we have these fellows down here that introduced SolidWorks, and that brought engineering onto the desktop. So that's kind of the flow of information, but as you know, you have these huge gaps. 1452 all the way to 1793, smaller gaps. We're up to things happening now like this. We're talking 3 months, products are reintroduced. Things are just speeding up more and more all the time. This is what I call the design spiral, and unfortunately, this is the way a lot of us end up doing our product development in companies, and we try not to do it, but somehow we always fall back into this. So this is what we have to break out of. Let's walk you through this. First of all, we get a new project. It's introduced from sales and marketing. We need a certain project. First thing they'll do, they'll give you a little brief. They'll toss it over to industrial design, and then industrial design gives their input. And then, lo and behold, you have a solution that looks great, but it works like hell. Okay, let's toss that thing over. Since it works so badly, we're going to toss it over to engineering now for their input. The engineers work steadily on this thing. All of a sudden, we have really something that works great, but it looks like hell. Not again. So we're going to toss it back. A little bit of time passes. We fiddle with it, toss it back to industrial design for a little bit more input. A little bit more time passes, and then, time is up. This thing's got to go to market. Let's take a summary of what we've actually produced here. We have an average product with below average sales. What's our grade for this project? Better luck next time. Let's talk about our challenge at Electrolux. Erica's first seat of software that she sold to us was right at the beginning of this biggest project that Electrolux had ever had. Here we are, a global company. In the United States, we're known as Frigidaire, Tappan, White Westinghouse, O'Keefe and Merritt, Poulan Weed Eater, American Yard Products. All of those are Electrolux companies. But this was the biggest input that we ever had to put into our company to be able to just do business. We're known mainly in the white goods area as Frigidaire. And as Frigidaire, we sold mainly refrigerators. That's the biggest thing that comes to mind, Frigidaire, refrigerators. In 2000, the Department of Energy, the DOE, had mandated that we would no longer be able to sell any of our refrigerators because they didn't meet DOE standards for 2000. And most everybody in the entire appliance industry was in the same spot. So we had to totally redesign every product that we made. We had never done something so huge before. It cost about $200 million. And we had to redesign every single part in these refrigerators with the exception of a little fan, little plastic fan we were able to carry over into the next thing, but everything else brand new. Thousands and thousands of parts. And we had to do it in just under 2 years or take huge tax digs at us because they wouldn't meet the standards. We had to do it or basically get out of the refrigerator business. In 1989, here's the way our design center looked. We were known as White Consolidated Industries there. We became Frigidaire, bought our name back. We're now Electrolux globally. Our design center was in Hilliard, Ohio. We had 22 industrial designers working on all the different areas. The designs were basically documented. We were still on the board back then doing 2D design. Then we moved into a program called VersaCAD, which was a 2D design program. You'd work for 2 or 3 days to document your design. We would do mock-ups and prototypes by hand. And then the product development time for those was about 5 years. And we talked maybe one line of products, maybe something that ran down, say, assembly line number 5. We would replace maybe 2 refrigerators. Take about 5 years. Well, let's see what happened as we go to the next slide here. Industrial design circa 1998. At that time, we were known as Frigidaire Home Products. Our design center was in Anderson, South Carolina. We had 11 industrial designers, and basically, during that project, it shrunk all the way down to about 3 or 4 industrial designers. Just incredible. 22 designers down to 3 or 4. SolidWorks 98 Plus was introduced. Mock-ups and prototypes were then made by CNC and SLA, and the product development time had shrunk to 2 years. What an amazing challenge. And we weren't really sure we could do it. Why did we choose SolidWorks at Electrolux? Basically, parametric modeling. It allowed changes much quicker. You could literally go on the screen, jump into something, and make changes as you're working. Now, the problem was at Electrolux in Europe, they're using more surface modeling programs, Alias, they're using Rhino, those type of things. Good products. Unfortunately, you have to know where you're going from the beginning, and after you reach a certain point, there's no going back unless you want to spend a day or two redoing all of that. The parametric system works so much better for us. You can go back and forth. And it really makes a lot of sense when you get into the project itself. The simple and powerful interface was very important for us. I know you engineers there are techie types and early adopters and so forth. Sometimes designers don't like that tech stuff. They just want to get in and they want to work with the form and they want to work with the way it operates and things, and maybe don't jump on that CAD stuff right away. Well, we found that SolidWorks was so incredibly easy to use that it was one of those things where people actually jumped forward and said, hey, we're getting another seat, I want that one. That one goes at my desk. And also, we have a special problem that we had to work with. Our engineering standard worldwide at the time was CATIA. It's also another Dassault company. When we brought in SolidWorks, we had to make sure that after we designed in SolidWorks, we could get those files into CATIA, and we could take the CATIA files and bring them forth into SolidWorks. And this was something we weren't sure we could do. Well, we finally got a program that would allow bidirectional translation, and it works extremely well. And of course, we're talking excellent price and performance on SolidWorks as well. Here was our development process. The project design, the designers that worked on the project, we had to learn SolidWorks as quickly as possible. As a matter of fact, something I'll be showing you a little bit later here was a very interesting mechanical solution that had been worked out just after using SolidWorks for 2 weeks. We made SLAs and proved out the entire design in 2 weeks after sitting down the first time in front of SolidWorks. We would do some rough sketches. We would model in SolidWorks. We would do PhotoWorks renderings for our marketing and sales people to use to tell them where we're going. And also, we would do conversion of files to CATIA once we were done. Here are some of these development images I was talking about. Do you see that? The one on the right here that says recessed lug system. This was an idea we had for holding things onto the refrigerator door. And it's something you can sketch up, but you really won't know how it works until you make the 3D part itself. And this was done 2 weeks into using SolidWorks. And it's one of those things that really, you can't build it on its own. It has to be built within the assembly mode of SolidWorks, which is the incredibly powerful part. And you'll notice that we're doing also some very sculptural forms and things that you would normally only associate with using surface modelers with, done in SolidWorks. Here are some development images. These are the first prototype refrigerators. Yeah, they're made out of MDF plywood and so forth, but they actually open up and you can remove all the parts. So you can see the number of parts just in this one refrigerator alone, and then multiply that times everything the Frigidaire makes. Huge, huge project. This is the ice and water dispenser. This is one of the things that has the worst reliability record throughout the industry. If you have one of these side-by-side refrigerators, I see people nodding their heads here. If you have one of those refrigerators, 2.5 times during the life of that refrigerator, you'll get it replaced. Replaced or worked on by a serviceman. And so that's one thing we really had to address. And we did that with SolidWorks. And one great story, I've got to tell this. Someone was working with a PTC product. I don't want to tell you what product it is, but it's called Pro-E. And guy was sitting right next to me. I had designed a part for this unit right here. And I sent it to him, and he called me up and he says, you know, I can't figure out how to make this thing. I said, what do you mean? You can't figure out how to make it? He said, I just can't get it to work. So he came down, he drove down with his little portable $20,000 portable computer system. It's like a mainframe. The lights dimmed when he turned on the switch. What I did in 5 minutes, I showed him how to construct it in SolidWorks in 5 minutes. It took him 2.5 hours in the other product. Oh, I was so happy. These are the production units that you can see on the floor today. You can see the ice and water machine, which, by the way, the ice and water dispenser is working terrifically. And these are all the parts on the final product. And again, we did this in 2 years with 3 seats of SolidWorks. We're growing now. It's moving over to Europe. And the project has just been an amazing success. Our engineering vice president, Tom Thompson, says, and I took this quote from him about 3 years ago, figuring out someday be able to use it. It's amazing, it's fast to learn and use, and at low cost too, which I think is fantastic. SolidWorks was then chosen as the Electrolux USA Industrial Design Standard. It's now moving into Europe. And a recent development, There it is. Electrolux Europe is purchasing their first several seats of SolidWorks. Here's our new challenge at Electrolux, and now we're talking about the way we develop products, and we're looking at every piece of the experience of buying an appliance. We have a new CEO, and this new CEO, Hans Strawberg, has several mandates for us at Electrolux. First of all, product development is number one. He thinks that engineers and product designers are incredibly sexy. They're the future of the company, and I think he's probably right because we have such overproduction in the United States. Electrolux is in a white goods market that we have Maytag, and we have Whirlpool, and we have Amana. We have all this overproduction, and we're using that continuous design spiral. And what does that do? It gives us these products that are just Me Too products. And the problem with that, all of a sudden you have just a commodity. What happens? What's happened to the appliance market in the last 10 years? Have you been paying more for the product? No way. No, if this is the same thing, you'd be able to buy a car today for $5,000 if it had taken the same trip that we're doing with the appliance industry. Prices have actually dropped, features have gone up, and all this with all the inflation that's going on. That's a commodity market. We got to get out of that commodity market because, as we were saying earlier with Peter, he said, you know, these companies are making 3% profit, 4%. I believe GM was, around 3% profit on their cars. It's just ridiculous. Let's go on to the next step. This is the big old cigar chomping business leader. And the push system is what a lot of us use at this time. But we got to move to something called the pull system. Let me tell you what the push system is all about. Push system is optimizing new designs to leverage high volume manufacturing, to be the low cost leader to increase the market share. Basically, we can make all this stuff so doggone cheap, and we can make it so cheap they're going to love it. Okay? But everybody can do that. There's not a whole lot of ideas being shifted around here. We need to move to the pull system where the end user is the one that is being considered here. The person actually using the product, they hear about this product. Maybe they see it in a store somewhere. Maybe they see it in an advertisement. They want this product so much that they're asking for it. They're pulling that product through the system. And you know, once the product gets there, it's what they want. It works much better. Basically, it gives the consumer what she wants and what she doesn't yet know she wants. Surprise and delight. That's what they do here at Disney World. They surprise and delight. Did anybody have those pretzels yesterday? Anybody try the cinnamon, the cinnamon cream cheese? Talk about surprise and delight. They were fantastic. I'm pounding them down. Here's our new process, and I've been working in Europe for the last 3 months, and we've done our first line of Electrolux products that'll be introduced here in about 3 years. This is the way we're doing it. We get research to attain consumer insight, and insight is more than, hey, you know, I think I'd like to have a clock on my range. It's things that you really don't even notice, but add to the product experience. The people that have bought new cars that we were talking to earlier, when you get in the car, do you notice that many of these new cars, you open the door, the dome light just fades up. And then you get in and that dome light fades down. Take a look at it next time. It's something that you really don't even notice. Or maybe the little bing buzzer for your key, if you leave it in there, it fades up and fades down now instead of just stopping. It's that feeling of quality, and you're not really sure where it comes from. It's the entire consumer experience that is now what makes a complex product successful or not successful. We analyze this consumer product experience. We design concepts for that experience. Then we take these ideas and we say, does it fit into the brand Electrolux? Electrolux stands for this, 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 and this. Does it fit? If yes, it continues on. If not, we toss it out. Then we create solutions. We call these solutions emotional ergonomics. You've heard that form follows function. That was the old world. The new world is emotional ergonomics. It's okay that it works and that it looks like it works and that you know where your hand is placed immediately without having to read an instruction manual. That's all well and good, but it's accepted now. We've moved into something now, does it comfort? Does it give you the experience that we want? You know, some people actually enjoy cooking. Some people actually enjoy doing their laundry. We found that out in research, which blows me away. But they actually enjoy it. They like what they feel like after they're done doing that laundry. They like the smell of it. They like the sound of that door. They feel like they've accomplished something. That's all part of that consumer experience that we need to capitalize on. Product semantics was something that we had on the last slide there. Product semantics are making sure that what it looks like it is, it is. What it looks like it works exactly like you think it does without having to read the instruction manual. And we make things resemble something that you can relate to in life, and you bring it over to a product, okay? I'll just go that far with it. It's a very complex system, but you should be able to know how to use something merely by looking at it. At this point, we did qualitative research on the models, trying to filter some more ideas. We created multidisciplinary development teams. We brought together everybody. We're not tossing it over the wall anymore. We're bringing together engineers, marketing people, salespeople, industrial designers, and creating this product all the way through so everyone has a voice. The qualitative research I've talked about. The marketing program then is developed to consumer targets. This is something we normally did at the end of the process. It's like, look what we made. Okay, how are we going to sell it? Now we're trying to develop that all the way along as we develop the product. Consumer interest pulls the product to the retailers. That's the final idea. It pulls it through the process. Here's our newsflash. Designers have to communicate better to all disciplines in a corporation. Engineering, manufacturing, marketing, sales. What does that mean? That means we have to use the tools at our disclosure. What we're using for the most part is SolidWorks. We have all these other tools. We have Photoshop, we have Macromedia Freehand, we have Animator, we have PhotoWorks. We have all these different tools that we can use. How do we bring them together to better communicate what we're trying to do and the ideas that we have? How do we do this? Use SolidWorks. Makes you look like a superstar. Beautiful renderings that we've done in PhotoWorks. A few weeks later, they say, hey, can you send that model over to Philadelphia because we got a trade show? I said, never existed. It's just a rendering. Animation also can help the engineers and marketing people understand the way that your design is working. That's how I refer to marketees. Let's go quickly over prototyping technology. This is another way to communicate because although you can work at something very small, if you try to do a knob or you try to do a handle, some way that you open doors or something, you're going to get fooled if you do it on the screen because it's not real. It's not real until you actually see that 3D product because your hand has to reach in there and fit in a certain way. I remember when we first started using CAD, one of the problems was we designed these knobs and they'd come out about this big. You put it on there, oh my God. It's one of the things about a prototype. At Electrolux, we use a stereolithography, SLA system. One thing's great, it makes very high resolution parts, and those parts sometimes are able to be used in a prototype to see if it actually works. Another one of the technologies, selective laser sintering, SLS. This is cool. Rocketdyne, who made the rocket engines for the Apollo spacecraft, they now make parts of their rocket engines using this SLS process. It makes actual metal parts that you can use. This one is fused deposition modeling, FDM systems. I think there's one that's displayed over here in the partner pavilion. That's a very nice and very fast way to get plastic parts that you can actually use. And next we talk about powder binding technology. Look at this little illustration that I stole from the internet. It shows how that works basically. And you can see one of these 3D printers that you can actually put on your desk. They're very inexpensive. I believe they start at about $600. And it makes it out of starch. And you can literally have that part in just a few hours. That's a fantastic and inexpensive technology just about anybody can afford. Okay, let's talk about what we've been doing with SolidWorks at Electrolux. We have a wide variety of images here, and I'll try to show you how we use different technologies to put it all together. This is our headquarters in Augusta, Georgia, and I took a photograph. It's about the size of a football field, bottom right. Looks like a big football field in there. We wanted to make that workspace work a little bit better. And people don't normally associate SolidWorks with working interiors, but it works great. You can see the layout we did digitally here. And then we rendered this center section. It's like a sales center. We rendered it up in about the same perspective and laid it right into the actual photograph. And it actually communicates very well. As I was saying earlier, we have American Yard products, and we make quite a few things for Sears, which is the Craftsman brand. Here we did some color studies and also little parts that were on this lawnmower, and you'll see that we designed new wheels. Those are SolidWorks wheels. We did them in different colors. We made just the little part itself. We rotated it into the right position, took it into Photoshop, shrunk it down, stuck it right on the product. Changed the color of some of the decks in Photoshop. And so we had a combination of those two technologies that worked very well together to make illustrations. What would have taken several weeks to mock up all these things, you can do in a couple of hours. This was not designed by SolidWorks. This is an actual Electrolux product. It's not sold, but the engineers at the Indian factory, they don't make lawnmowers in India, so they decided to cobble this thing together. You notice it has the product semantic of a mushroom-shaped cloud. Here's a refrigerator. This was done just purely, this is about an hour or 2 hour project here, putting together what might this new Electrolux concept look like. And we actually made little 5th scale models of this, and then took a Photoshop picture of those, put it into the layout, and it looked like it was a full-size product with all the reflections. Here we're taking a look at what maybe is the next generation. We have new DOE standards that are coming now to laundry, which means that basically the top loaders are going to be changing mostly to front loaders because they use 10% of the water. Your clothes last about 10 times longer. The pollution is much less. It's really a much better system. We were thinking, what would the top loader look like if we continued it into maybe a tilted axis machine? And you can see that we've done kind of an X-ray view through it here. That's all through SolidWorks with a little scaler we've put in from Photoshop. And on the right side, you see what would happen if we wanted to make this laundry center for apartments. And again, you can see that the unusual things are tilted axis and those type of things, all shown in X-ray view. Over here we see, we did an AEG kitchen display for one of our trade shows. All this is done in SolidWorks, every doggone bit of it. And if you take a look, we didn't have to model all of these little bottles in this refrigerator. That basically is a map. It's a decal that we put on the product. I took it out of a catalog, as a matter of fact, scanned it in, placed it right on the side, as well all the cooktops. Those are all just bitmaps that are in there, put on as a decal, and wow. You're cheating, but it works pretty well. Communicates the idea. We did the same thing here. This was for another trade show. Those are bitmaps that were laid in as decals. Saved me a lot of work from having to render up an entire cooktop section, which could have taken an hour or two. Here we see another trade show. This was the Electrolux booth, and everything you see there was done in SolidWorks except for the guy. The guy was one seat down at the design office. Took a couple of shots of him, laid him in. It looks like it's a real place. Even the furniture, SolidWorks. Another example of the same type of idea. Here, this was a little 10-minute design that was done. We were doing a retro range for Kenmore, and we needed something to stick in there to make it look real. Made a little teapot. Look at those cool reflections. How would you like to have one of those in your, in your kitchen? This is taking that idea of using an internet, associating with a refrigerator, and possibly you'd be able to go onto an internet site that would give you cooking ideas right there on the screen. And these would be blow molded doors or rotationally molded. Again, same thing here. And these are little parts for refrigerators. Shows you how that assembly mode is so fast and so important in SolidWorks. Look at this. What's amazing here, we were able to do this on an 800 megahertz machine. Now just imagine a few years ago being able to tell somebody they could do it on a desktop machine that's rather slow. With all of these little parts and so forth, we were able to rotate it easily and be able to do that on a very inexpensive machine. And as you see on the left, there's the SLA model of the actual product that we made. We actually do some sketching from time to time, a few little sketches, showing then our little model along with the logo that we put on the front, done in SolidWorks. And that's about it. I thank you very much. SolidWorks has been a wonderful experience for us, and I'm sure it will be for you in the future. Thank you.
Doug, thank you. I'll grab that. Peter, Doug, thank you both very much. I can tell you, I know the guys at Electrolux got it right. When you went into that laundry scenario, deja vu. You're right. In my house, the first thing that goes, there's my wife right there, she can attest to it, the laundry is being done before the coffee is even being brewed. Secondly, I can tell you, did you notice that little subtlety in one of Doug's slides there, where he said, give the consumer what she wants? Now you know who's buying the products over here.